So welcome to today's OTT. Today we're going to take a look at Effect, which is a fairly new technology that is leveraging TypeScript and the entire ecosystem that we already know of NPM, all the packages we get to install, both in the front and also in the back end. And Effect is making something quite new for basically TypeScript developers that want to write type-safe code that is production ready and that is dealing with really complex workflows that often take a lot of testing, takes a lot of code to be written to get to production ready result. And Effect is introducing a number of concepts, and we can use those concepts to build what they are calling effectful applications. And I'm really excited to show you how this new library works. So let's dive in. I do have a demo to show you, so I just want to highlight the main website. In the main website, you're going to get an introduction to Effect. So maximum type safety, they use some really complex and some really good types under the hood so that you as a developer get a really nice experience working with types and working with errors to make sure you're handling every error in your application. Much better than try catch, if you ask me. Last year, I already gave an OTT where we talked about better error handling in TypeScript, where we basically use the result type to handle errors. And Effect does that and much, much more that you're going to see. As we were talking in the intro, it makes code composable, reusable, and testable. It's really robust in that sense. It has an extensive library that is growing a lot. I think you'll find that there's still a lot of room to improve, especially in documentation when it comes to the ecosystem. But recently, Effect reached sort of a general availability with its core package. So Effect core is stable while the ecosystem is still growing and still needs work. This is quite interesting. It's starting to happen in alpha. I'm following closely this development of clusters. I really want to see what this is going to result, but if you know, for example, languages like Elixir or any language that builds on top of the Erlang runtime, they basically get out of the box because of their virtual machine being this powerful tool set to create applications that are distributed and are super safe in terms of runtime errors, something that we lack with many technologies. If you get an error, you have the risk of your application stopping altogether. That is the case with Node, Python, any of the common languages, and even Go if you're using for web backends, you're going to find that you could get in a deadlock situation that causes your application to panic. And that's something that distributed technologies, like as mentioned, Erlang have solved. And Effect is bringing a solution to the TypeScript world with this Effect cluster, but it's still not something that we can use. But it will be very interesting if we can use TypeScript in a similar way that these very robust technologies can handle today. And something else that's is very highlighted here in the website is how Effect differs from regular TypeScript. So in here, they're doing an example of error handling, how you would do without Effect. So we're used to the fetch function, to the await, async await patterns that returns promises. So we know very well this, but we need to write really imperative code to get things going. With Effect, we're writing basically declarative code. So we're saying that we want to make this GET request, and we're going to fetch OK. We're going to parse it to a JSON. That's pretty much it. So these two pieces of codes are comparable. And as we start to expand the logic, so let's say now you want to do retries, the imperative code starts to get quite complicated. We need to declare variables. We need to keep track of number of errors, attempts. We need to manually create promises. So you can see that the chances of getting things wrong here starts to increase. And just the time that it takes for you to write this piece of code is also may not be super productive. While if you are in an effect code base, you're going to be able to just add effect or retry with exponential backoff up to 3 times. And it's going to be 4 lines of code. And as we get more complicated, we get also the ability to do interruptions, which in effect is just 1 line of code to say, we want a timeout in 1 second, and we don't need to care about all the details that we used to do, let's say with an abort signal, an abort controller, and all of that. And observability out of the box, you're going to find that effect is really focusing on these production ready needs. So OpenTelemetry and tracing metrics, all of that is something that effect already has a good support, and it has some dev tools also that help you do it. So you also get a 1-liner here to do tracing, which is really nice. So I'm going to go over to VS Code and show you a little bit of code, but please stop me if you have questions along the way. So here we have a scenario that is somewhat common. Let's say you want to do a piece of computing. It could be to call an HTTP, let's say a post. You're going to post something to an API, but imagine that that API has a limit of concurrency. So if you ever call that API more than, let's say, 5 times at a time, it's going to fail with a 4 to 9 rate limit error. So of course, it may be an old downstream system, so they want to protect themselves. So they introduce that limitation. Now, you as an app developer, when you integrate with such API, you have to be careful, and you have to write code in a way that you avoid ever going above that limitation. Now, if you're trying to think how you would go about solving this issue, you may install an external library to do it. That's all fine. But if you're writing effect, you're going to find that you're able to use the effect ecosystem to solve this problem. And in this case, I implemented the solution using basically a queue. So if you're familiar with a queue, queue has 2 sides. One side is putting items in a queue. The other side is consuming items from the queue. So that's a solution that is very natural to do when you want to limit concurrency. Basically, you create a pool of workers, and you create as many workers as you want to have concurrency. So I set here a value. This could be an environment variable or a configuration. I set it to 2. Let's change this to 1 in our demo. Queue, many things that I may not go into detail, but basically here we're running an effect where we declare the queue. So here we're initializing a queue that doesn't have any limit. You can create a queue that can only fit a certain number of values, but you can also create a queue that fits an infinite amount of values. So that's what we're doing here. We're fitting as many values as come in, but we still want to have a way to limit the concurrency. And I ended up implementing something very similar to Go. So if we take a look where this concurrency value is used, it's used in a for loop where we say yield run. We could call this yield run worker or start worker for a better name. And basically what this does is for each concurrency that we set, we start a new worker. So we have a pool of workers that are created as daemons. So that means that they continue running regardless of what's happening. I'll show you later why that is, but this effect here is going to run and is going to spawn one worker per concurrency. So now we set to only one. We're only going to have one of these running. If we take a look at this code, you're going to see that these workers, they run forever. And we have some observability here so that we can track where logs are coming from. So logs that happen within this effect are going to have this span worker daemon. And in the logic itself of the worker, I told you we're using a queue. So the first thing that a worker does is it takes from the queue to check if there is any work to be done. If there's no work, this yield clause is just going to wait. So it's going to wait until it gets some work to do. And all the workers are going to do the same. If we have multiple ones, and once one worker takes an item from the queue, the other workers are not going to take. So of course, that's really important as we don't want workers to be doing duplicated work. If you want to create that scenario, Effect has a different component that is called pub sub. And this is basically, if you know AWS, it's like SNS integration with Lambda, for example. So you can put, you can put a message, you publish, and the other side can subscribe as many times as it needs. So that's a very common pattern that we might need to solve for. In this case, we're using queue because we have a problem where we want to limit concurrency. So we're taking items from the queue and we're going to do some work. And while we do that work, we added those things we saw in the website. We add a timeout of 2 seconds. We add a retry with exponential backoff. So to me, at least, this is natural to read. But of course, if you're not used to like functional programming and this style of piping values, this may look strange to you. We have a couple more things going on here, but something that's interesting is that the value that we take from the queue, not only does it have the work that needs to be done, so in this case, we're just doing work with a number to do some math. We also get from the queue a deferred, and this is a value that we can use to say that this worker failed or this worker succeeded in its task. And well, we can take a look where this deferred is used, and that is on the other side of the problem of the producer. The producer is the one that creates events for the workers to do their work. And in this case, you can see that we take the queue service, and instead of taking values, we are offering values to the queue. So the producer is going to offer the value and also this deferred. And with this deferred, we can do an await so that whatever work the worker produces, we are going to return. So that's pretty much the producer side. You can see it doesn't know anything about how the worker is going to produce. It doesn't know anything about how long it takes, how many retries it did. It only cares about the final result, which could be a success, but it could also be a failure. And if you're new to Effect, you're going to find that the types are very useful to help you figure out which things you need to run effects. So for example, this producer, in the type annotation, you get to see which values it returns. So it returns a number, which is the calculations we're doing. It may error with an error. So this is just a generic error, but we could tag and annotate this error to be custom to our application. The last parameter is dependency. So these are things that we need to provide to run this effect. So the producer cannot produce any events if it doesn't have a queue. It needs the queue to put events in and receive events from. So that's a dependency. Then once we run the application, you're going to see that we need to provide a service. So we run this program. So once to set up the workers, that's what we do here. We create the program, we pass in the queue and its implementation. You see that I have an implementation for the live code. You can also have an implementation for testing where you have mocks. So Effect is ready to do tests. And as you can see, we're doing dependency injection using this provide service. We do provide service for the queue, and the worker also needs an implementation of a worker. So we provide this here, and then we run this effect here. And in the produce side, we run similarly. We need to provide the queue. So we provide it here. Every time that we produce an event, we pass a different parameter for n, and then we run. So it was tricky for me to figure out how to do this, especially because, well, I had an effect running above and I needed this effect right here to share the same queue. So that was tricky to do, and I didn't find too much documentation on the subject. It was a lot of trial and error. So if you want to do something similar with effect, I can share the code with you. So now let me run this thing so you can see it live. So let's run this effect application, and we already see many interesting logs. So for example, I've put logs when we were creating the queue. It tells you the level of the log, the time, and it tells you in which fiber it's running. If you're familiar with Golang, I see fibers as Go routines. So this fiber number 0, it's one Go routine that is running. Fiber number 1 is a completely different execution environment. So this one is creating the workers. Fiber number 2 is a fiber for a producer of events. Fiber number 3 has the worker daemon, and you can see that it says, hey, I'm ready to do some work. We already know from the previous log that the producer already put some work in the queue. And then the same fiber number 3, you can see it was almost pretty much at the same time here, 12 milliseconds. It was ready and it already had work to do, so it started doing that. The worker itself that runs in a different fiber says, I'm doing work. Then it says 1 second later, you can see here, it said, I'm done. And then worker finished. So, well, we can test the scenario to see if this is actually doing what we wanted. So what if we put 2 events? Are they going to run synchronously? Remember, we put the limit of concurrency equals to 1. So once we run this, we should expect this to run once, and then you see there's a certain delay. There's a 1 second delay until these 2 over here run. Now, if we change the concurrency to 2, we're going to have 2 workers doing work. So instead of taking 2 seconds to compute all the events, it's going to take 1 second. So it completed much faster. You can see by the timestamps, it completed in roughly a second. So yeah, I didn't show you about errors, but I also implemented something. If you see here, the worker, let me make this bigger. The worker is running here. It sleeps for a second, and if it takes an even number, it fails. So we can try to put an even number just to see what happens if it fails. So of course, this could be a request that returns an error. I think I need to make this like this to see the entire log. So we run. Interesting. We're getting some errors. Let's see. We have concurrency set to 2. Okay. So in the logs, we can see that we started getting errors, but the application kept running and kept doing what it needed to do. So this fiber right here terminated with this error. It said, I can't work with even numbers, and it gave us the stack trace, so we can know where that happened. That's exactly where it happened. And you can see that this error happened not just once, but it happened, let's see how many times. Let me search for it. I can work with even numbers. We have 3 attempts. No, okay. So just an explanation here. We have 4 logs. That is because we tried to do this 3 times. So 1 time once the effect ran the first time, plus 2 more times that we asked to retry. And then here we have a final log. That is only the log that we get outside. So a question that you might have is, okay, I'm going to implement this effect library in my project, but now my entire project has to be rewritten. That's not the case. You can actually implement effect in specific domains, in specific parts of your application, but the output can be just a regular promise. So you can see here we have promise void, and we can just use this in our application using promises. We don't need to change everything to be written in effect. So that could be a concern that you have, but it's not the case that you need to rewrite everything. We can even change these info logs to change the log level to info just to see if we don't care about effect and we just want to see on my application what's happening after changing the log levels, except for the main one that I didn't change, you're going to see that the logs look much cleaner. And you can see that we got a result from this event. We got a result from this other event, right? We multiply this by 2, we get 1 by 2, we get the 2. Multiply 3 by 2, we get the 6. But the 2, because it's an even number, it was never able to complete. And it took a while because it was retrying with an exponential backoff. We can play around with this application if we want. So let's say we want to make the timeout half a second. So this is going to be a problem, of course, because the application takes 1 second loading. We have a simulation here. So if it takes 1 second loading, but we have a timeout of half a second, none of the events are going to succeed. They're all going to be retried 3 times. And you can see we start to get these timeout exceptions as they finish. So we get 3 timeout exceptions. And yeah, that's, I think, pretty much it. I think it's a lot of content for such a short period of time, but I wanted to give you an intro that you may not find on other YouTube videos about how do I actually use effect and what does it look like at the end. If I just care about the final promise, that's not a problem. You can see that if I remove these handlers here, the final type that I get is just a produce event that takes whatever input and returns whatever input as a promise. So you don't need to effectify your entire application. And that's pretty much what I had for today. Thanks a lot for joining. If you have any questions, this is the time.
I have some
Hi, Jose.
questions. Hi, Marcelo. Great presentation. I missed the beginning. And first of all, regarding effect, to me, looks like a kind of framework or library that you can apply to your project. And that the effect from, I missed the connection between Golang effect and what you're showing. So when you are well, I don't understand what is written in Go or Golang, or what is the difference between Go, Golang, and how do you connect it to effect. And then regarding the uses that you show, my main question is about the resources and how you can implement and put all these things in AWS, since you are showing like queues and etc. or topics. How does this work in AWS and match with the services that we usually use? What is the main use case where you are using all these patterns, right?
Yeah, I got it. Thanks for the question. Let me go on the first one. So I was mentioning Go and making parallels between Effect and Go, mostly because I think both technologies are dealing with concurrency in their own ways. So while Go, the way they implemented concurrencies, they want to be as effective, as efficient as possible, as fast as possible. So like a really good garbage collection. So Go is oriented towards like workloads that require performance. They want to maybe even save on cloud costs because Go requires less memory to run compared to other technologies, and it can use multiple cores really efficiently. So in that sense, I think Go is a great technology. But since we're using TypeScript on the front end and sometimes even on the back end, we get TypeScript across our applications. And I don't think there's a really great way to write good concurrent code in TypeScript. Nothing even close to Go, of course. So what Effect is basically a TypeScript library that allows you to write concurrent and production-ready code in TypeScript. So you don't need to change your entire technology to use something like Go or Elixir or these technologies that are very concurrency oriented. You can still use a regular TypeScript and JavaScript, but then you write this application with Effect to get all the benefits that I was trying to show in this presentation. So at the end, with Effect, you're never going to get performance like Go, but at the same time, it could be that performance is not the biggest bottleneck of your application. You may be fine running TypeScript in the backend, so you're going to be fine using Effect. And yeah, just have a more production-ready code base that is more tolerant to failures and is able to retry, is able to have exponential backoff, and all these things. What was your second question?
It
Oh,
was about
about
the resources or AWS. Since I saw that you are creating here queues and thread at some point with multiple workers, how do you, or what is the proposal here to deploy? Or looks like at some point in some section of your presentation looks like a kind of DevOps language that you can use to deploy some component of an architecture.
yeah, that is a great question. When I think about integrating Effect in, let's say, a cloud native environment, there's going to be some overlap, so some duplication. So the way that I wrote this application, it's meant to run, let's say, in a single node. It's not prepared to run to horizontally scale. It's not prepared to do all of that. If you are going to, let's say, change this queue implementation to support a cloud native environment, you would probably refactor this so that instead of creating and using the native queue component of Effect, you would create a service. Probably the signature would remain the same. You would have a queue.offer, queue.take, but instead of doing all of that in memory, you would call SQS to put a message, and you would pull from SQS to get these messages. That's probably how you would implement. But it really depends how much do you want to rely on AWS services to do these things, how much operational costs do you need to spend to set up queues, right? If you're using good infrastructure as code technology, as we usually talk about in the OTTs, that you should use something like Terraform or CDK, then you're probably good to go to just create a queue and implement yourself. But if you don't have like a good DevOps experience, or you don't have these things set up, let's say all you have is a single node running a TypeScript server, I think Effect is a good way to make that a more robust service than it is. This is a scenario that I faced with an application that there was already a TypeScript backend running with an Express service. And all that I wanted was to basically take this demo that I gave, and instead of having a number that I do math, I had an API that I needed to call. And that API had all of the restrictions that I mentioned. limited the concurrency that you needed to call, and it also would sometimes just fail for no reason. If there was a big event, that API could just be busy and return 500 errors to you. So the exponential backoff helps a lot with just making sure that your request finishes. So that all worked for that stack. I didn't have to create more infrastructure. I could just use the resources that already existed. So those are some parallels that I can think of.
Okay, so really nice presentation, first of all. Seems to be a great tool for JS development. Just a small question, so we don't spend too much time here. This thing on working with queues and in a way wrapping your code inside effect. Do you know how all this behaves? Knowing that JavaScript or Node, it's not multi-thread. Does effect do some tweakings or any special thing for this thing on parallelizing work to work in a good way? Also, take into account that I'm not following latest JavaScript updates, so maybe they are relying on some new features which I'm not aware of. I don't even know if it's ES6 or ES7 even. To be honest, I'm not following. So do you know if they're taking advantage of some new features or how they handle this
Sure,
concurrency?
that's a great question. Today, I was actually listening to a podcast of the creator of Effect and trying to learn more and get more in depth with the technology. And yeah, from what I read and what I heard, it doesn't have anything special to do with concurrency. So it's still relying on the event loop. So everything runs sort of in a single thread, and you have to be careful not to cause locks. Effect has this runtime, and the runtime is pretty much the model that allows you to coordinate these threads, but it's in quotes because they're not threads. It has nothing to do, nothing even close to Go, for example. Um, it's still normal JavaScript. Um, it just changes the way you really write code. So if you're going to do something very CPU intensive, this is not the right tool. You still want to go to something closer to the assembly or something like that, something closer to the binary. If you're writing TypeScript, JavaScript applications, you're really at the high level writing like application workflow, orchestration, and doing the thing that Node does very well is like scripting for I/O applications. So I/O is like you take an input from a web server, you make a bunch of calls to the network or to the disk or to a database, and it takes time for them to complete. And Node is very good at context switching. So Node is going to be very fast at doing something, then okay, I need to do something else, or now I need to do something else. And that's pretty much what we saw in this demo. Once we see these logs and we say, okay, fiber 0, fiber 1, all the way to fiber 9, these are all really virtual concepts. They do not reflect a green thread in the application, like Go, for example. So we're not looking for performance here. We're looking for a better way to write TypeScript. But there is some hope to your question. Uh, as I mentioned in the very beginning, Effect is working in this clustering. So it's still not going to be great for doing CPU intensive tasks, but at least if you have a cluster and multiple machines, you can start to distribute work across them. At least that's what I understand they're going to do. I'm looking forward to this because it could really change how we look at TypeScript and applications. Instead of writing multiple microservices in the future, we could be writing this sort of effect applications, much like Elixir, which I need to learn more about. But one of the great benefits is that it gets out of the box this ability to work within a cluster and send processes across and be very efficient at that. I'm really excited about this new library. It's not going to be a competitor to Go, but still in the TypeScript world, I think it's a great new thing. It's getting me quite interested in learning. Does that answer?
You answer. So it's more oriented to orchestrate and coordinate work inside an application, totally. So not suited for CPU intensive tasks, although there might be some that it could also handle. So yes, really interesting, really robust. It seems like how JavaScript should have been in a way.
Yeah, they
Really
are
great. Thank
marketing
you.
themselves as the missing standard library for TypeScript. I find it a very funny marketing. Of course, not even close to reality because it's a complete change in paradigm. But it's still like they're using TypeScript to its potential, like to its full potential, which is really nice to see.
That's great. Yeah, I think that this type of functionality it's there in all the languages and also in compiled languages like Java, C Sharp. I don't know if all these features are there, but most of them are because of its nature. And I think it adds those nice things to JavaScript, which it's great.
There's some history here that I was listening in the podcast. The author had some good experience with the Zio library that I think is from Scala. And he basically borrowed a lot of the effect concepts from Zio. And it's pretty much like an effect in a different technology. And I find it really nice because, they're not taking these ideas out from their head. They're actually taking these ideas from things that have been successful in different ecosystems, like you're saying. And, probably Scala has good typings to allow this kind of code, similar to TypeScript. It has a really powerful type system. If you change from TypeScript to other languages, at least I feel like very limited to how much I can express with types. And yeah, Effect is taking that to a next level. So yeah.
Totally. One last question. You are mentioning TypeScript. Effect is tied to TypeScript, or you can use it on plain JS?
I would say it is tied. You're not going to find the benefits of Effect without TypeScript. For example, in this small code base here, as you hover over the values, you get to see, as I said, the return value, the error, and the dependencies. And you just don't get anything like that with plain JavaScript. So, like, of course, if you take a bundler and you transpile your code from TypeScript into JavaScript, this is going to run just fine, right? So in here, I'm running with TS Node. If we are to bundle this to a .js file, it's going to run, but I would say during development, you want to be using TypeScript to be able to have all these effects. In fact, let me show you this. This is super interesting. So, for example, if you come in here and you don't provide a service that is required to run your application, you get an error during, let's say, compilation. So you truly are not able to run effects unless you pass in all the dependencies. And of course, this implementation here doesn't need to be one. You can inject whatever implementation you like, right? I can do like a fake implementation, and I may need to wrap this in some kind of effect dot something here. And you see this works. I'm like basically mocking the service. But if you don't provide, the application is not working. And you get this because of TypeScript, and it's really, really great.
So all this relies on TypeScript logic.
Absolutely. For the typing, for all the autocompletes that you get, for the type safety, TypeScript is doing the magic over here. This was a great OTT. Thanks a lot for the questions.